Hi, everybody, and welcome to the Sierra Club Airport Marina Group's first online long-distance Zoom meeting. Happy you are becoming charter members in our online outreach using Zoom. I'm Richard Harmel. I'm a member of the Airport Marina Group Executive Committee, and I'll be your host this evening. For starters, I want to let you know that this meeting is being recorded. Before we get to our featured presenter, we're going to go through some technical pointers and protocols, and then we'll be going through some announcements. Probably a lot of you are already familiar with Zoom and how this all works. I know some of us may not be, so first some technical points. During this meeting, I'm asking that your microphones all be muted and your videos turned off to be able to present her talk without any interruption. If you scroll down to the bottom of your screen, a toolbar is down there, and toward the middle of the screen, you'll see the chat icon. So when you click on that chat icon, a chat window will appear to the right of your screen. And then down at the bottom of the chat screen, you'll be able to send messages to everyone in the meeting. You can type in comments or questions, and then when you're done typing, you want to hit the return key on your computer and your message will be sent and will appear on the chat screen. For this evening, if you want to ask a question, I'm asking that you type in an asterisk first and then type in your question. And that asterisk lets us know that that chat message is a question, and then we'll be responding to those questions as the evening moves along. Also at the bottom of the screen, for those who are not familiar with this, if you click on the participants icon, a participant screen will also open up to your right. And there you'll see some nonverbal responses for you to use to the moderator or the speaker. And you can use these various icons in order to respond, or you can use them to let everybody know your impressions. So under the more, you've got thumbs up, thumbs down, clapping. You have yes, no, go slower, go faster, all of that.
Don't be using that thumbs down.
And that's from our presenter, so you better pay attention. So next we have some announcements. Tomorrow evening, Wednesday, April 22nd, Earth Day at 7 p.m., the Culver City Democratic Club is going to be hosting a meeting on the climate crisis in the era of the corona crisis. And there are going to be two great speakers, R.L. Miller, who is the chair of the California Democratic Party Environmental Caucus, and Patricia McPherson, who we know, who is the president of Grassroots Coalition and is a member of our executive committee. The second announcement is we were invited by Barbara Hensley of the Central Group to a meeting tomorrow. It's a Sierra Club Live forum at noon with State Senator Holly Mitchell, State Rep Sidney Kamlager-Dove, and Culver City Council Member Daniel Lee. And they're going to be discussing what elected leaders and community activists are doing to stand up to big oil in Los Angeles. And finally, next month, we have on Tuesday evening, May 19th, the Airport Marina Group is going to be hosting a Zoom meeting featuring David McNeil. You probably know David. He came and spoke to our group a while back. David is the executive officer of the Baldwin Hills Conservancy, which operates under the National Resources Agency for the state of California. He oversees the long-term acquisition and planned development of approximately 2 square miles of open space into much needed parkland for urban Southwest Los Angeles County. And David's topic is expanding the Baldwin Hills Conservancy to the ocean. So that should be a really interesting talk. Tonight, we're happy that restoration ecologist Dr. Margot Griswold has agreed to share her insights on what restoration really means. So, as president of Los Angeles Audubon, Margot oversees Los Angeles Audubon Society's environmental education program. And what began as her passion led her founding and initially funding Nature Demands Action, a Los Angeles Audubon Educational Endowment Fund. Also, as founder of Earthworks Restoration, Inc., that recently merged into Land IQ, Margot and her staff are well known for revegetating and reclaiming drastically disturbed landscapes, such as landfills, roadways, water projects, and monitoring them for mitigation. Also for assessing and monitoring exotic species, and for projects involving restoration and some creation. Margot is past president of the Society of Ecological Restoration California chapter. And she gets very excited about urban core communities as a key component to achieving long-term conservation nationwide. LA Audubon supplements LAUSD environmental science studies by developing LA Audubon's educational outreach to Los Angeles Unified Schools. You may not know it, but 80% of the students live in circumstances with little access to nature. She is interested in guiding urban students who are paid interns in the program and who mentor younger students in environmental stewardship, creating a workforce in the fields of natural resource management, environmental science, urban planning, and environmental education that reflects a true diversity of communities. So Margot Griswold is going to show us what restoration looks like. And she's going to be using examples of her own work on the Ballona Bluffs and other locations as they progress from an idea to a mature restoration. And just before you take this on, Margot, just want to remind everyone that if you have any questions, please enter them into the chat. You can hit the chat button down at on the lower toolbar, and that will give you access to your chat. So Margot, it's all yours. Take it away.
Okay, and you're gonna get rid of me, yourself, and Beverly.
I'm getting rid of all of us here at the top.
Okay. Well, welcome everyone, and thank you for tuning in. And I hope we're all being safe in this time. I must say, putting this together has taken me back down memory lane. I'm in kind of semi-retirement, I guess, and I still keep my hand in it a little bit, but looking back at all this, I was able to not think about the present. So it's helped me. So I hope you are interested and have some questions. So what I wanted to kind of build on the last speaker who talked about soil and how wetland restorations are not living up to what they should or could, mainly because lacking of soil components. And so I'm going to touch on that as well as I go along, because soil is everything. My company's name was Earthworks, and our motto was from the soil up. Without the soil, we couldn't do anything. So I learned a lot about the soil in the early years. And so I feel lucky, even though I'm not a soil scientist. I've worked with a lot of soil scientists. So everything I talk about tonight, you have to understand, is always a team effort. There's always many different people working on these projects with different expertise, and I'll remind you of that as we go. And so I want to reflect on what habitat restoration is and an approach we can take to restoration and enhancement of Ballona wetlands. And the reason I want to focus on this is because I think people throw the term around, and I'm kind of precise about how I like it defined. And not only that, but the state has a precise definition on what you can do in wetlands, and restoration is all you can do in wetlands that are within the coastal zone. So I think it's important to understand what restoration is. So it is the process of intentionally altering a site to establish a defined indigenous historic ecosystem. The goal of restoration is to emulate the structure, function, diversity, and dynamics of the specified ecosystem. So it has to have been there recently. Creation, on the other hand, establishes a historic ecosystem. So it could be somewhere in California, in Southern California, but it never was on the land. So it was not supported where one person is trying to do this particular habitat. So creation establishes a historic ecosystem on lands that did not previously support that ecosystem. I didn't make this up. It's from the California Society for Ecological Restoration, but it's what I lived by. And just for the record, I've done restoration, I've done revegetation, I've done land reclamation, and I have done some creation. And I can tell you that I would never do creation again. It's very difficult and takes a very long time and it's just not satisfying. Very difficult. So I mentioned revegetation. What's the difference between revegetation and restoration? So revegetation establishes a historic native habitat on a drastically disturbed site with no natural soil horizons, so no organic A, B, C horizons in the soil, no soil ecosystem, and little to no seed bank. Whereas restoration establishes a native habitat that once, more than likely, occurred on a site with more or less natural soil horizons, a disturbed soil ecosystem, and an infinite weed seed bank, generally. So it's a degree of disturbance when you're using the term revegetation versus restoration, and I'll show you some examples. So this is an example of revegetation. So here we have a roadway being built through an open space in Orange County, the 73 toll road, which I was the project biologist to manage the mitigation and to make sure that all the regulations were followed. And so this is the soil on a slope in 1994. You see it is nothing but subsoil brought to the surface, filling Bomber Canyon by a lot. 1995, the slopes are built. This is 4 benches. Each slope is 70 feet long, or high, I should say. And then a bench, and then 70 feet. So that goes down 4 big benches. And I'm standing at the bottom taking this photo. We've now seeded the site, and I used some of the brush that was cut prior to building. We set it aside and we put that at the toes of each of the benches. And so here you see in 1997 what the seed mix has done. So this is what I term the living mulch. This is a native grass that we seeded heavily, along with all the other seeds we were putting on. So we put our pioneer species, our grasses, our forbs, subshrubs such as deerweed, and also what our target dominant revegetation would be. All seeded at the same time, but what comes up is, in the first few years, just the pioneering species. And that's following a succession model based on observations from fire. So it doesn't happen instantaneously. 1995, we seeded. 97, you see what it looks like. And by 2001, this is the habitat. So after 6 years, the target shrubs began to dominate the slopes. So what's restoration then, if that's revegetation? Well, we can define restoration as a reestablishment to return historic natural functions to a site as previously existed, or rehabilitation to improve the general suite of functions of a degraded site. And usually rehabilitation is less disturbing than just reestablishing. So let's look at West Bluffs for restoration. So these are the slopes, you know, above to the south of the Ballona wetlands. They're a sandy, sandy bluff. And this is what they looked like when we started the restoration. It was mainly wild radish, short pod mustard, and annual European grasses, with a shrub here and there to give us an idea what it might have been. Research into the historic notes and photos of what had occurred there previously gave us the indication of the coastal sage scrub slopes. So again, following the succession model, we planted all the species at one time. We seeded them after preparing the slopes. So in that revegetation project, you saw how bare the slopes were because the soil had no seeds in it, and we had a blank slate to start with. We added everything, like an artist. Here, there's an infinite amount of seeds in the seed bank. So we had to do site prep for a year or two before we would seed. And once seeding occurred, then the usual pioneer species came up as we expected, but we got an unexpected boost. If you see this gray-green plant all over the slope, whoops, I gotta go back. That is Nathallium, pseudo-Nathallium, I think they changed the name to, microcephala. It was not in our seed mix. We had Pseudo-Nathallium californicum. But this was on the slopes. We didn't see it before we started. It was being suppressed by the wild radish and the mustard and grasses. But as soon as we controlled those, it jumped forward. So, and then this is the development, as you see in the second and third year, we start getting more of the shrubs. A few dry years, and 2010, I think, was a good year. At any rate, we achieved the performance here, and this is in 2020. So it's still looking even better than it did in 2010. So that is simply weed control, no equipment except for weed whackers to take out the non-natives before they flowered, raking off the thatch so we had a seed bed, and then seeding, and then, you know, several years of hand weeding followed. That's an ecologically efficient way to restore. No spray, no weed whacking once you put down your seed. It's hand weeding. It's hard work, but it pays off. And this is just a video of the whole slope from Cabora Drive. We did have some revegetation on the West Bluffs as well. This was filling Hastings Canyon outside of the coastal zone. Within the coastal zone, there was no filling allowed. No bulldozers could go on the slope in the coastal zone. I'm going to repeat that. The Coastal Commission wouldn't allow any bulldozers to go on the slope of the coastal sage scrub, degraded coastal sage scrub slopes. But outside the coastal zone, they filled the Hastings Canyon erosion feature, and we then had the clean slate of a revegetation slope, and this is the development, much as you saw in the earlier photo. And I would like to point out that we had, here's the manufactured slope, the revegetation slope in the background. This is the restored area here. And at the last minute, the Coastal Commission threw another 12 lots at us. And that's here. And this is an area that was added and didn't receive the same pre-treatment in the same years, in the same intensity. So you see that without that site preparation, it's difficult to achieve the type of restoration you really want. So here's a general trajectory of habitat development that you see whether you're in revegetation or restoration. So here we have year, and here we have percent cover on the y-axis. And you see that pioneer species start out, they jump to the fore, they germinate almost instantly, and you have a good cover for erosion control and to protect the soil from raindrop erosion as well. And meanwhile, your target species, in this case, we've been looking at coastal sage scrub. Those target species are developing so that by around year 6, you start really seeing that, and the pioneer species are falling out because of shading. However, they've seeded, they've all seeded. So if you had a catastrophe such as a fire, you would have your seed there, your pioneer seed would kick in after the fire, just like you see in nature after a fire. And we've seen this happen in some of our projects that have burned after maybe 10 or 15 years. They come back without any seed being added to develop after a fire into the target habitat. So this is our generalized model. Let's see. There are other components that come later after the 6 years, from 6 to year 15 or so. And here's a, oh, sorry. Here's a Dudleya multicollis, which is a rare species in Orange County that was added and came up later. This is the Nathallium, and here's Nathallium, Pseudonathallium microcephala, who was not on the West Buff slope, but came up after being released from the mustard domination and the wild radish. Also, Pseudonathallium will take years to come up in a restoration, in a revegetation area. So because there's no soil development and it needs a particular soil companion to develop, it does not appear until after around year 10. And so that brings me to the secret ingredient of all revegetation, restoration, you name it, in the soil are the mycorrhizal fungi. Now they're tiny, as you might think from mycorrhizal. There's 2 types. There are ectomycorrhizal fungi and arbuscular mycorrhizal fungi. So the ectos are a lot on trees, oak trees, pine trees. Many trees have ectomycorrhizal fungi, as you might think, they're on the outside of a plant root. I'm showing in this diagram the arbuscular mycorrhizal fungi, which actually goes into the root of a plant between the cells, and what the mycorrhizae do, but whether they're ectomycorrhizae or arbuscular mycorrhizae, they act as a extension of the root system for plants, and they absorb water and they absorb nutrients, especially phosphorus. Now, this is really important in Southern California because our soils are very low in phosphorus. And that's, as you know, one of the three main nutrients for plants. So mycorrhizal associations help 80% of plant species. 80% of plant species. That's not just on the dry uplands, but also in wetlands. Recent studies show that all wetland types support mycorrhizal fungi. So any kind of wetland, a freshwater marsh, a saltwater marsh, you name it, there will be plants there that form a mutualism with these microfungi. So I say a mutualism. I've told you what the fungi give the plant. They absorb water and phosphorus, but the plant gives the fungi its food, because fungi are not autotrophs like plants. They can't make their own food. So it is a mutualism, costs a little something for the plant, and that's how mutualisms work. You get something, you give something. Also, I think it's very interesting that recently they've found that the ectomycorrhizae, and I believe the arbuscular as well, are thought to be like the soil internet between plants. So this is how plants can communicate. They set up a net. So these hyphae go not only into the root, but they go between the roots. And especially in the arbuscular mycorrhizal fungi, they aid in maintaining soil structure. So they have a protein called glomalin, and that forms a glue-like protein. And along with humic acid is really thought to aid in soil structure, the formation of soil, and the structure of soil is very important to oxygen. Oxygen is needed for the roots of all plants. So you have to have pores in the soil for oxygen to be there. Without that, you get compacted soil. And we all know nothing grows in a dirt roadbed that's driven over and over, mainly because it's compacted and there's no oxygen for plant roots. So AM fungi are extremely important. Help reduce the soil erosion because of that glue-like glomalin. And certain of the early successional plants in our model that we use have a very strong association with AM fungi and vice versa. So you want to favor seeding many of those early successional to build your microfungi net, and then you have a great ability to have a very good soil, absorbs water, holds water, and aids in plant development. So another really interesting thing, and I witnessed this, I observed this myself. There would be sites where we had weeded, and now our plants were very well established. And I would see this army of mustard standing exactly at our boundary, as if there was a wall. And I thought, well, that's funny. Look at that. Why is that? And I started reading and asking questions, and some of you may know Ted St. John, who was an early proponent of using mycorrhizal fungi in restoration, and I learned a lot from him. He said, well, I think they're antagonists. And sure enough, I was looking around for things to put on the website, I mean, on the presentation tonight, and here was a non-mycorrhizal plant. Well, all mustard family is not mycorrhizal, none of them. So don't add mycorrhizae if you want to grow radishes in your garden. It won't help them. So apparently, here we have the net in the light gray. That's aiding in the roots of these other plants, while meanwhile, there's antagonism going on and inability to absorb and an inhibition of root physiology. So there you have it. Mycorrhizae helps us fight the weeds in particular types of weeds. Unfortunately, not all weeds are not mycorrhizae. Is that the right way to say it? Anyway, if anyone has any questions here, I'll stop at this slide and you can ask.
Yeah, hi, I'm back. So Leslie had a question.
Yes.
Going back to, can you hear me?
Yes.
Okay, so Leslie had a question going back to the slides on the bluff and was asking, was that white sage to the right of the last slide on the West Bluff?
This one? That's microcephala, pseudonathalium. I don't see any white sage.
Okay. And then Richard has a question. What is the timeline for the buildup of the microfungal?
So the timeline is, in a restoration, usually you have mycorrhizae in the soil because you haven't drastically disturbed the site. And so I rarely have to add mycorrhizae when doing a real restoration. You do add some, especially if you're putting container plants in your site, because they'll come inoculated. Mm. It's very rapid. We did tests on the slope I showed you on the toll road. I had Irvine Valley College students out, and we took root samples and we measured the distance from the container plants, because in those days we were, it was dogma that you could not hydroseed mycorrhizae with your seed. You had to add it in an inoculated plant. And so on that first year on that project, we planted liner plants 10 feet on center of stipa to inoculate the soil. And then we measured that after a year and a half. And we found that the mycorrhizae had moved approximately 1 meter. And it moved from that inoculated plant because we had seeded with very friendly mycorrhizal pioneer species that had come up immediately in the first year and the second year. Mm. And so the roots of all those plants were moving the mycorrhizae through the soil. Mm. So it's quite fast. If you take if you take topsoil, which we did, we were able to get some topsoil on this project. On another part I'll show you momentarily, you can get immediate results in the topsoil. Every plant you sample that is mycorrhizal will have mycorrhizae in the first year. So that's the best way, but to take topsoil means you have to take it from somewhere. We were working on a road project, so it was a balanced cut and fill, so we could take where they were taking out good habitat and store that topsoil, crush the vegetation and store the topsoil.
Thank you for that. We have a couple of questions that are referring to how do you protect wildlife, and how does the recovery of wildlife species intersect with restoration of a plant community? That's from Marcia. And then another question about how do you protect the insects, birds, and animals when you do a restoration of ecosystems, and what happens to these species if it takes up to 6 years to revegetate?
Well, they didn't have any habitat there.
Yeah.
So many species you're restoring, so the species nearby are going to have that coastal sage scrub habitat. So what you have is wild radish, annual grasses, and you are going to take that habitat for that 1-2 years of site preparation. So you won't have the same amount of habitat for your skippers or bees that might be using that radish. Because it's a restoration and we're not doing anything in the soil, all the soil organisms are fine. And in fact, you saw the seeds of the pseudonathalium is released, actually. So you're benefiting that species. We didn't have any loss of gophers. I can attest to that. In a restoration, it's more minimal disturbance. In a revegetation, because it's a project that drastically disturbed the site, it's the project that disturbed the soil, and so you're putting it back. When a project like that goes through, it is devastating. It is one of the hardest things I've ever had to manage, trying to move snakes, lizards, rabbits, squirrels. It's the only project I did that I had to do that. But so in the restoration, it's easier. There is a time frame of which that first season you're going to be getting, all the plants are going to be flowering, so you're bringing back bees, and you might have some more native bees rather than the European bees. So it's a fairly short time in a restoration if you're doing a successional model. However, that depends on how long you have to treat the weeds. And so when you're out there cutting the weeds and then the rains come and then you cut the weeds again and then the rains come, that could go on for 2 years or so. So depending on the size of your project, you would phase that work so that there was habitat for even the species that were using the less desirable target, less than the desirable target species.
Okay, thank you, Margot. I have a couple more questions here, and then we need to move on. Marcia wants to know, first of all, not just protecting, but the recovery of wildlife. And she's also wondering, shouldn't we or whoever is planning restoration be asking questions like, what does the least Bell's vireo, the endangered songbird, need for recovery?
Well, yes, and I'll get to that in the next slides. On these projects I was showing you were for coastal sage scrub species. So least bells are going to be in the lowlands. rather than on the slopes. Blue-gray gnatcatchers, I was hearing those within 3 years on the West Bluffs. On the toll road, we've had within the 4th year, we could start hearing a California gnatcatcher, which was the target species for that habitat. So you can get a fairly quick recolonization. And in the next slides, I'll talk a little bit about that. I hadn't planned to, but I can. Okay.
Okay, moving on. Thank you.
Moving on. So restoration can be divided into 2 activities, reestablishment and rehabilitation. And the reestablishment returns the historic or natural functions to a site as previously existed, and rehabilitation improves the general suite of functions of a degraded site, usually resulting in less disturbance. So I would say the West Bluffs were a rehabilitation in terms of restoration because there was less disturbance. What I'm going to show you now is a creek restoration, and this is a reestablishment because the creek had been pushed around so much. Here is Bonita Creek in Orange County, and this is the floodplain of the creek. The creek had been pushed over into a small culvert, and this had been being farmed and used as a plant nursery. And the slopes on the side are cut slopes. They're more or less natural, but they were cleared. Here's year 1. We established that the slopes were coastal sage scrub based on historic evidence. We looked at the watershed for Bonita Creek, which is 25 square miles, and we anticipated in 1994 what full build out of the area was going to be in and around Irvine and Newport Beach, and based our hydrology estimates on the full build out, because that would be more hardscape and more water likely coming down the creek. We also did in-depth hydrology, groundwater hydrology. So we knew, for instance, upstream here at the beginning of our project, the groundwater was 16 feet down. So plant roots had to grow 16 feet, the willows and mule fat and cottonwoods. And so that meant I had to have a temporary irrigation system to get them down that far, because they wouldn't happen in the first year, because we were planting live cuttings. You can see them, these little sticks in the ground here are all live cuttings of willows and mule fat. The slopes, as I said, were coastal sage scrub. So it's interesting that these slopes, this is 3rd year again, you see these are our gold fields blooming, all the early successional species still in abundance. You start to see the shrubs coming up, and especially here in the front where there was more shrub cover left during the project. And you start seeing the willows and mule fat take off. So you also start to see over here the beginnings of construction of this housing development. That was home to about 10 pairs of gnatcatchers. I had nothing to do with this housing development. But the great thing was, as we developed the habitat, those birds came over here. And so the population of gnatcatchers in this area remained stable through the creation of a road and the creation of these housing developments on the other side, as well as the Lisbell's vireo. So they were living just upstream in a thicket of willows. And they went through the construction of the road, and then they took up residence all the way down the stream, along with a southwest willow flycatcher. So within about 7 years, the Lisbells were moving in, and the southwest willow flycatcher. This is the downstream portion, and this is where groundwater was only a few feet below. And so you see in year 0, we're planting the live cuttings. It was a wet year, and we had to put our planters on styrofoam blocks to be able to walk out and get these in the ground. It was a late spring, sort of like this spring. But even in the wetlands, we have the same early successional species. You can see them here: cattails, scirpus, and the starts of the willows and the mulefet. Year 3, you can see a little more of the tree development, but still early successional species. I was kind of astounded by a Corps of Engineer person who I said, "Hey, have you seen Bonita Creek?" He says, "Yeah, it's nothing like you said it was going to be." And I was kind of stunned because it was year 3. And I thought, what does he think? It can happen instantly? No, it took 6 years before I even saw the beginning of the indications of wetland soil developing here. And that goes to last month's speaker, what she was talking about. It takes time for these things to develop, a long time for the soils to develop to what it was originally. But by adding mycorrhizal fungi, you are aiding, because mycorrhizal fungi are found in all types of wetlands. They just did in 2018, a review, a meta study of all the other studies of mycorrhizae, and they found that it's not well understood, but their role seems to be in wetland plant communities, the composition, succession, and diversity. So that's something to look forward to in research to come. But here's the habitat still developing in year 6 with the upland coastal sage scrub. And it's resilient because this is 24 years later. No maintenance required. And here come some of the bigger trees. At any rate, part of the success of these habitats is looking at the soil and making sure you're adding mycorrhizal fungi to your soils. So looking at Ballona, we know what's out there because a lot of people have been looking at it. You have to do your site analysis for landscape position, soils, watershed hydrology, local hydraulics, and the current vegetation distribution. Now, some of these things we haven't gotten, like the hydrology. There hasn't really been a good study of the hydrology for the project to restore Ballona wetlands. The site analysis always has to include what wildlife are currently using the site, to Marcia's question. You have to know that. And you should do a historical analysis. So in the most recent years, historical ecology has started to come into its own. In the early days, you had to go to track it down, and various different libraries had aerial photographs. You could go back in history, you could read notes, you could try to determine what was there. But these historical ecology studies are just invaluable to see what was there in historic times, what is compatible with the current and future conditions. And then you define your goals based on that, and standards for the site, given the current local and regional conditions. You want to look at the region. And then you start defining your methods, approach, timing based on plant and animal species. So that's, again, how you determine how you're going to protect. And not every project will give you that great a timeline. BALLONA is different. BALLONA can have whatever timeline it wants to protect. And then you start defining your target vegetation, seed lists, and the like, and soil amendments such as mycorrhizal fungi. And that's something we don't have yet. We haven't seen that. And then it goes on to define the methods, how you're going to get rid of weeds, for instance, and the timeline, phases of implementation, and then define establishment maintenance, methods and timing, implement the plan, and then you monitor to adjust that establishment maintenance as needed to achieve the goals. So just a quick look at BALLONA this year, and I guess we know it holds water. Here's the area B up near where they used to drain the water out. Those drains have been plugged. Here's the salt pan. And here are some small pools along the way to the salt pan below the current freshwater marsh. So this is what was predicted by the historical ecology of the BALLONA Creek watershed, 2011. So the more recent science indicates what BALLONA should be if you're going to restore BALLONA, if you're going to enhance and rehabilitate and reestablish. It's never was a full tidal wetland. And I hear people talk about historical ecology like, oh yeah, well, that's just one T-sheet, or you can't base anything off that. Well, yes, it's not just one T-sheet. It's the compilation of the historical record using older maps, T-sheets, irrigation maps. All of these things go into account and assemble the report. It's not just one thing. It's many things, and it's a science. It is a science, and it's so valuable and should be used. You know, I've thought I knew what things should be, and I've been proven wrong. And it's, you know, everyone thinks they might know something, and then when they're shown the facts, you should be able to say, oh, I was wrong. Let's do it the right way. And I think that's what's kind of missing here in the approach to the BALLONA wetlands. So again, more recent science, a classification, a model that shows how our Southern California estuaries are mainly closed and were not open. And I think looking at regionally, you can see in the historical, the acres of salt marsh, salt flat, which is our salt pan, seasonally flooded with fresh water. You can see what they were, and you can see the contemporary. So the change has been only 12% loss of salt marsh, whereas the salt flat or salt seasonally flooded is 90% lost. Brackish and freshwater marsh, 54% has been lost. Whereas, look at open water mudflat, that's the title. 615% increase. Now this is a study from northern San Diego County, but you can extrapolate that if you just look at Orange County and what's happened there as well. And it's a homogenized group of estuaries now, fully open, and trying to keep them open is difficult because, as predicted in the model in the previous slide, they will close, and you have to spend your money keeping them open. So I think rather than turn Ballona into just another full tidal marsh at great expense, why not look at her and say, you know, what can we do more efficiently? What can we do that's more in line with the rainfall, the runoff patterns, the groundwater that needs to be protected? What can we do rather than come in here and dig it up? And let's start with Area A because they seem to have changed a bit their tune in areas B, south and north. So these are some of the species we see. And some more. And you can see that the center of Area A was most likely a wetland and not a tidal wetland. You can see we still have Fiji ditch here, which is a riparian, you know, it gets a tidal influence, but it also must be getting some freshwater flows just based on the vegetation in there. So I know this is an old slide of weeds, the weed load, the non-native percentages, but bear with me because I looked at their more recent, they didn't actually present the data this way. And so I am using it this way. I went out and walked along the edges because I can't go in. No one can go in. So just walking along and looking at the vegetation. And I was looking for all the black mustard they said was in here. And I do see a lot of black mustard along Lincoln. And a little over here, but not too much. But mostly I saw short pod mustard here. And I saw a lot of chrysanthemum, some castor bean, and euphorbia. And I'll just say that we know how to beat the mustard. Addition of mycorrhizal fungi and mycorrhizal plants, seeds. Do some weed control. Weed control of the short pod mustard. Chrysanthemum, I believe, based on my experience in the Baldwin Hills, has a very short-lived seed. So we don't have to fear the seed bank as we do with the mustard. That's good because chrysanthemum's a mycorrhizal plant. but we can pull that plant up easily, and it holds on to its seeds for a very long time, so it's very forgiving to get rid of. I think we've done a really good job just with volunteers in the Baldwin Hills in the last 10 years. Euphorbia, similarly, we've gone after that in the Baldwin Hills just by hand. That one you have to kind of cut off. Euphorbia and castor bean are related. Gophers don't like them, but they're kind of obnoxious plants, in my opinion. But you can get rid of them. And you can do it without chemicals. You can do all these things without chemicals. The other, if I can get my cursor to move, the other cool thing is there are these big areas of native plants, California sagebush, you have laurel sumac, and then of course the Lewis's primrose, which is an endangered species. Those are found there. So of course we have to do surveys before and map out where you will and will not weed, and if you're going to go near the primrose, carefully. We're doing a project right now in Laguna Beach where the crownbeard is, and so far your Sierra Club compadres there think we're doing a great job protecting those plants and getting rid of the mustards out of the area. So it can be done in an ecologically efficient way. And this is an example from Sandy DeSimone with National Audubon at Star Ranch, where she manages 4,000 acres. She uses no herbicides. This is artichoke thistle dried and already gone to seed. This is what her test plot looked like when she started. This is after a few years of cutting with weed whackers. You see the artichoke thistle here in its rosette form. It bolts, they cut, and they do this repeatedly for several years. And here they've seeded then finally when they have few enough artichoke thistles that once were a monoculture, and that's how her habitat developed. No herbicide. Just hard work though. But you don't get anything without hard work. So the design alternative that I would suggest is to base it on the most recent science from historical ecology and models of closure patterns, and from citizen science observations, of which we have many. Avoid impacts to landscape features that have been stable for the last, at least 150 years or more, such as the dunes, the salt pan, and the brackish marsh habitats. Don't remove the levees. Just keep those Ballona Creek where it is now. There's just some things you can't really change. What good does it do to release that water into this wetland in just that last mile? It's a strange idea, if you ask me. The creek never flowed like they're showing it in any case in the plan. The creek stopped up about Lincoln, and it just sort of were fingers going out, much like you see Sentinella Creek now still flowing on the south side. I would reduce the tidal channels to avoid draining the brackish and fresh wetlands, because that's what tidal channels will do. And put in new tide gates if they need to actively manage to, create that diverse condition. And conserve and enhance the native biodiversity. So including the brackish marsh and meadow and tidal marsh, upland and rare endangered species. And you know these are all Jonathan Coffin's photographs by area. And it's just a lot of species, bird-centric, because I am Los Angeles Audubon. But there's also an amazing assortment of insects, or you wouldn't have the birds. There must be voles, there must be for the raptors to be feeding on, as well as other small birds. There are butterflies, skippers, and mentioned the primrose and the burrowing owl. So even up in C, the much maligned C, there's opportunities to create and enhance what was there, not create, but enhance what actually is there. Some wetland features that occur. We still have Fiji ditch coming through. So there's, I think, things that just haven't been explored to take advantage of, to do really an efficient, ecologically speaking, efficient restoration. And that's it.
Okay, that was great, Mark. You took us on quite a journey there. I have a few questions for you, and then we can address those and then continue on. Roy wants to know, why are only plants considered in restoration, and thus plant ecologists driving restoration? He says, why not recover early successional animals in early stages as well, such as insects, small lizards that use dead wood, rocks, perhaps small mammals, alongside the plants? I do not see animals being recovered later with restoration called complete without translocating animals.
Well, I think that depends on whether there are, in a lot of my sites, they have been natural areas adjacent. So in fact, they do colonize. And I know that because even on some of those revegetated slopes, I wouldn't imagine, when we had to go back and put wildlife fencing, move it from the outer edge of the right-of-way right to the road edge for better protection. We had to be digging holes and to put in these great fence posts. And I was amazed after it was a 10 or 15 years what we would find, because we'd have to go every morning and make sure nothing got in those holes before they started doing the fences. And there were some interesting snakes, lizards for sure, in those areas. So I think it depends on what's nearby. And I agree, yeah, plant people are usually at the forefront, but I don't know, I work with a team of soil people, and we usually have the wildlife people telling us what the goals are, be that US Fish and Wildlife Service or California Department of Fish and Wildlife. And sometimes it's lizards, sometimes it's, what are those, spadefoot toads, sometimes it's birds, sometimes it's making connections for coyotes to use a habitat to get from one to another, such as using Bonita Creek to get to the upper Newport Bay, where they were needed to control red fox, who was preying on the clapper rail, or the formerly named clapper rail. So I agree, in some projects that is true, but in a lot it's a moving group of why do many of these projects get done? They're done for mitigation. And so the target species come down from that, usually. But Ballona is different because it's not a mitigation. It is kind of pure that way if we kept it that way.
Huh.
So you could, these are all good points to bring up in the planning, because it's hard to preserve soil organisms when you're digging it out with a bulldozer.
Yeah. Okay, I have another question from Leslie, but before I do that, I see two raised hands, one from Jeanette and one from Miriam. If you guys have questions, then please type them into the messaging, into the chat, so that we're able to see what those questions are. That would be great. Leslie wants to know, why is the open water mud flat so prevalent / preferred?
You mean when people do these mitigations?
Yeah, I guess so.
That's why. Because why are they so preferred? Because that was the target they had to replace. They were taking it out and they had to replace that somewhere.
Mm-hmm.
Also, I think it has like this. It has to do with people's perceptions. When you work with parks, they want trees. Shrubs aren't good enough. It doesn't matter. You explain many times that trees wouldn't live here. It's an idea people have that trees are better than shrubs. I think the same, if you talk about a coastal wetland, what do most people think? A tidal wetland. They don't think of a coastal wetland being a freshwater wetland, a freshwater marsh, a brackish marsh. They would think the salt pan was there because of the tides, instead of the salt coming from water evaporating from this slightly raised area, evaporating and leaving the salts behind. And they would be amazed at the life that's in that. To Roy's point, the life that comes out of the salt pan is incredible. So when I look at a plan that sprinkles salt pans around like they were, you know, willy-nilly, they don't understand what's in the salt pan. They would have to take that soil, they would have to inoculate everything, destroy it, it doesn't make any sense. But anyway, that I think is why they tend towards making more open water, full tidal wetlands, because it's somebody's idea that that's better, more productive. But I think what is not yet well understood is the role of microorganisms, soil organisms, microfungi in sequestering carbon. They're extra roots. I think you would see people thinking differently about it if they thought these other wetlands were as productive or more productive in terms of sequestering carbon. So it's a bit of a two-way thing. I think mitigation drove a lot of stuff, open water for ports, port projects. I know that, you know, clients have needed things, they buy land and they say, well, we need this. And I look at the land and I say, well, you can have some of that, but not all this land can be that. And they get a little annoyed, and then I do the mapping and we do the study, and yeah, the soils, the landscape position, whatever is wrong for that habitat that you want, but over here it's right.
Okay. Let's just do one last question. I want you to know that you're getting a lot of really great feedback. Margot, you got lots of outstandings. This needs to be polished and edited for publication to the web. You've really hit a home run here, so that's really great. I had one more question. And let me see. It was, I'm sorry. Walter, so Walter is asking, to what degree, I'm sorry, should natural recruitment, limited seeding and planting be relied upon in a habitat revegetation?
So that depends on what's there, how many, and how many species. I like natural recruitment, and I think seeding doesn't inhibit natural recruitment. And I say that because we saw such on the West Bluffs, and I've seen such recently in other projects down in Orange County. We're doing some cactus scrub restoration. But if the seeds are there and you release them from the weed suppression that's going on, natural recruitment is you kind of count on it, and you count on birds bringing in more from nearby. But you have to, be careful, because there's this fine point of weeding out the undesirables and adding the seed for the target species. You can't leave that unseeded for too long. You can start to see recruitment. So it takes a lot of being on the ground to see what's happening. I'm seeing the few plants we planted after weeding in the Baldwin Hills with volunteers, that certain species are just going gangbusters after about 4 years, seeding themselves to the point we don't have to do any more weeding. You tend sometimes to get a less diverse habitat if you don't add some other seeds that you want. So it's a hard question, Walter. It's a site by site, year by year. Because I'll tell you, some years things won't come up, whether it's the timing of the rain, the temperature of the rain. There's so many factors on why seeds, how seeds germinate, when seeds germinate. You really have to be out there looking at it, eyeballs on it, and that's why we have adaptive management. Adaptive management is not just a word, 2 words. It is something we use, and couldn't live without it. I've never written a plan I didn't have to go in and kind of tweak once I saw what was happening. So there's no hard and fast rule to it.
Thumbs up. You did a really great job. Jerry Rubin suggested that maybe we could have everybody come on screen here and maybe briefly introduce ourselves.
I'm here and I'm unmuted. Ben Hamilton and Margot and the team. I want to say you put on a fantastic program. This is one of the very best presentations I have ever seen, and the best about Ballona wetlands.
I agree with Ben's comment, Margot. Awesome. Roy Vanderhoek.
Why, thank you, Roy.
Yeah, great job.
I've seen some great ones from Walter and from you, Roy. I think everyone's done a good job.
We have a moment of silence recognizing John Muir and his work and honoring him. Okay, that's great. I don't know that any of us would be here if it weren't for him.
But thank you, Margot. This was terrific.
And I'd like to say I'm glad to see that Brody from the California Department of Fish and Wildlife joined us today.
Margot, I appreciated seeing the West Bluff and hearing you talk about that because it's still close to my heart. Thank you.
Yes.
Some of the plants out there that you had in your display, the Latin names, you guys, you know, Jonathan's good at it by now, Roy's good at it, but sometimes if you could just use the common names that those of us that are so used to the common names use, that'd be helpful too.
I thought I did use mostly the common.
Once again, thank you everyone for coming out and participating in our first Airport Marina Group Zoom meeting. You may be pleased to know you're all recognized from this point forward as official charter members of the Sierra Club Airport Marina Zoom group. So as you know, we'll be doing this again next month on Tuesday, May 19th. And so we're going to be drawing this meeting to a close now.
Wait, what about your presentation?
Well,
Please, it's so good.
let me see what I can do if I can pull it up. Okay.
Oh, beautiful.
So here we go. And so
Wow.
to commemorate Earth Day, I just put together a few slides here for your pleasure. So we all know, most of us know this photograph. It's called Earthrise, and as you see, it was taken from a lunar orbit by William Anders on December 24th, 1968 during the Apollo 8 mission. And nature photographer Galen Rowell called it the most influential environmental photograph ever taken. For the first time, we see a vision of Earth as this finite entity that we need to take care of. And so funnily enough, 16 months later, out comes Earth Day, April 22nd, 1970. 20 million people came out onto the streets across America, and an event that to this day remains the largest civic event in human history. Here's what it looked like in New York City. And what was, as you undoubtedly know, the results, unbeknownst to anyone at that time, the results were the establishment of the Clean Water Act,
Yep.
the Endangered Species Act, the establishment of the EPA, and the establishment of the National Oceanic and Atmospheric Administration, banning of DDT, removal of lead from gasoline, passage of the Toxic Substances Control Act, and the Marine Mammals Protection Act. Earth Day 1970 changed the trajectory of our country and probably the world. So from 1970, this was the future. Earth Day 2035 seen from 1970.
Still looks like that.
Now, if we're not careful.
All right.
Right.
We don't get
And
rid-
so here are things to do on Earth Day 2020. So this is the talk I'm talking. I had mentioned Culver City Democratic. Get your invitation. This is the talk tomorrow at noon, the Earth Day Forum. You can look that up on Sierra Club. This is the link for that. 2020, this is the Earth Day Live, and there are a ton of things that are going on this site. This is the whole several days, I guess, and there are going to be a lot of really amazing speakers happening there. This is linked up to Smithsonian, and there are, once again, a lot of great things. So here's from the Airport Marina Group to all of everyone here. Given the pandemic crisis, in the midst of the climate crisis, and all that we have to be thinking about and trying to keep safe. So happy Earth Day, 50th anniversary 2020. So thank you, everyone.
Yeah.
Yes.
Richard has done an absolutely phenomenal job starting out not knowing Zoom and just taking over and doing a masterful job. I'd like to thank him. And I would also like to thank Margot for an outstanding job. Thank you, Margot.
Just want to say to you, Margot, too, I think a couple of days ago when we met to talk about this presentation, I said to you, I'm really looking forward to taking this trip with you. And you fulfilled every expectation I had. You did such a wonderful job. Thank you so much.
Thank you.